So guys, this is our project on Netflix movie and TV show clustering. In this, we are gonna cluster and from our data, we are gonna make a Netflix suggestion system for unsupervised machine learning. Now project summary. The aim of this project is to analyze the Netflix dataset of movies and TV shows until 2019, sourced from the third-party search engine Flexible. The goal is to group the content into relevant clustering using NLP technique to improve the user experience through a recommendation system. So we are gonna make a recommendation system for Netflix which recommends movie as preferred as choice of the viewers. So this is the step-by-step process: handling null values in datasets, managing nested columns like that cast listed in and countries for better visualization, binding the rating attribute into categories like adult, children's, family, friend, and not rated. So this will also help the viewers to for the suggestion, performing exploratory data analysis to gain insight for preventing subscriber churn. Creating clusters using attributes like director, cast, country, genre, ratings, and descriptions. These attributes were tokenized, processed, and vectorized using TF and IDF vectors, reducing the dimensionality of the datasets using PCA to improve performance, employing K-means clustering and algorithmic hierarchical clustering. Developing a content-based recommender system using a Gaussian similarity matrix to provide personalized recommendation to the user and reduce subscriber churn from Netflix. So now let's start our project. Here we are importing our libraries. Import numpy as np, import panda as pd, import datatime as dt, and here we have also for visualization we have import matplotlib as plt, and libraries used for textual data we have imported string nltk and all the sequencing libraries to use to implement cluster. Now for clustering we have import sklearn metric, yellowbrick cluster, sklearn metrics pairwise, and all of this. Now here library of warning could exist in ignoring warning issues. So this we have imported for filtering the warning issues. Now loading our dataset. We have load our dataset. Now this is the first view of our datasets. So here we can see show ID, type, title, director, cast, country, data added, released, ratings, duration, listed in description. So this is the first look of our dataset. Now we are coming to the second point: dataset row and column count. So there are 7,787 rows and 12 columns of our data. Now data df info for so this is our data info: id, object type, title, director, cast, country. So here we can see. Now duplicate value. So the total number of duplicate value observed in the data set is 0. So it's good to see that we don't have any duplicate value observed in our data set. Missing null values. Missing values or null values. Now we are seeing that our data set has any missing values or null values. So for that we have applied null value count in each of the variables. On now percentage of the null values in each categories, null values of each categories in variable. So id 0, type d 0, title 0, directory 200 2389, cast 718, country 507, date added 10. So percentage of null values in each variable, this is the percentage, and this is the null value in each variables. Now visualizing the missing values. So this is a heat map which is showing the null values. So here we can see directors. This is the getting highest null values, and the list is in released year and in ratings. Visualizing the missing values. So here we are visualizing the missing values. So for that we have plot a figure and bar plot here. So here also we can see the director which we have seen earlier in our data, 2389. This is the missing values. This we have shown in bar chart. Forecast 718 and country 700 507. The dataset Netflix movies and TV shows clustering comprise 12 columns, which only one column have been an integrated data types. It does not contain any duplicate values, but does have null values in 5 columns: director, cast, country, date added, and ratings. The dataset provides a valuable resource for exploring trends in the range of movie and TV shows available on Netflix. Additionally, it can be utilized for developing clustering model to categorize similar titles together based on shared attribute genres of country and origin and ratings. Now understanding our variables. So dataset column, and yes, we gonna see that there is show id, type, title, directory, cast, country, date added, released year, rating, duration listed in description. These are all our data set columns. Now here we can see our data set describe variables. These all are the variables which I have read above. Now checking unique value for each variable. For that we have done for I in a for loop. So here we can see show id is 7787, type 2, title 7787, directory 4049, cast, country, date added, release, rating, duration, list in description. So here we can see the number of unique values in each variables. Now coming to another point, data wrangling. So handling null values from each features. For that we have used null values count in each of the variables. So here we can see null value count in each variables. Here we can see only directory, cast, country, date added, and ratings. These are only having the null values, and this is the percentage of that. Date added. So this is the date which is given, and the ratings. This is the ratings. Here we can see TVMA ratings, TV14, TVPG. This is all our rating. Now country. For the country we can see that United States 2555, India 923, United Kingdom 397, Japan 226, South Korea 183. These all, and rest are the countries. Since the data added and rating has very less percentage of null value count, so we can drop those observations to avoid any bias in our clustering model. We cannot drop a input any values in directory and cast as a null percentage is compromitably high, and don't know and we do know data of those actual movie, so it's better to replace the entire with unknown. We can fulfill null values of countries with mode. We can have 6% of null values, and most of the movies source from US only. Now inputting null values as per our discussion. This is for director cast, director cast, and df. So here we are importing null values of country with mode, dropping remaining null values, date and ratings. Now rechecking the missing values, null values count. Null values count of each variable, now it's become 0 and percentage also becomes 0 because we have rechecked because we have done inputting null values of country with modes. Now handling nested columns, directory and cache listed in countries. Now we have make a copy of our dataset so that any changes we are gonna do is done our new dataset. Here we can see our data. So unnesting directory column. Now here we have unnested our directory column using lambda function and split. So this is the data which we have got. There are titles this and director there. Now unnesting cast column. Here we have unnested cast column. Here also we have applied lambda function. Here we can see title, actors. Now unnested list in columns. As we have discussed, this also we are gonna do with lambda function. Title, genres, unnested country column. Now this is for country column, title and country. Here we can see all the countries. Great, we have successfully separated the nested columns. Now let's just merge all the created data frame into a single merged data frame. Now we are gonna merge all the unnested data frames. Here we are gonna merge all the data unnested data frame. So while merging we are getting this. This is the head of our data set. Title, actors, directors, genres, countries. Cool. Now let's merge this data frame with original one and left join to avoid information loss. Now we are gonna merge this with our original data set. This was merged with the copy ones. Now when, as we can see, the moment when we merged our data set with all of them, unnested data set, here we have got title, actor, director, genres, countries, type, date, added, released, ratings, duration, description. Now type cast of attributes. Checking info of datasets before typecast. df info. This is the info. Title, actors, directors, generic, country, types, data added. These all are the datasets before typecasting. Typecasting duration into integers by removing minute and season from the end. So here also we are using lambda function. Typecast of the object. Now checking the dataset after typecast. Now when we are checking, we can see that there are null count and data types. Binding of the rating attributes. In rating column we have different categories like rating classification that are commonly used in the United States and other countries to indicate from approximate of media content for different age group. Let's understand each of them, bringing them accordingly. So let's not complicate it. Create bins for as following. Now we can see for adult we are suggesting TV, MA, NC 17 and R. For children content TV, PG, PG, TV, G and G. Teen content PG 13, TV 14. Family friendly content TV V, TV Y7 and TV Y7 FV. So these all are the uh, these all are the which we are generally getting, these all are the rating attributes, and for this we are recommending the TV shows for adult, children, teens, family friend and non-rated, binding the values in the rating columns. Now rating map, here we can see adult content, teen, children, not rated, family, all we have listed here. Checking head after binding. Now after doing binding we are checking our head of the data. So here we can see title, actor, director, these all are, this we are getting. Now separating movies and TV shows. So here we have to separate movies and TV shows also. So here we can see 12,000, 1,26,079 columns and rows. What is the manipulation have you done in the insight you found? Now here we have divided the data wrangling into 5 different sections. First, in this section we have imputed drop null values. We have unnested values from the following director cast listed in countries. We have also typecast following, and we have also seen the ratings column content variable code categories. So also we have done a clustering on categories. Lastly, we have split data frame into two: DF movies that contain only movies and DF TV shows that contain only TV shows. Now coming to chart visualization, data visualization, storytelling and experimenting with charts. So first chart, the relative percentage of total number of movies and TV shows over Netflix. So by this chart we are going to see that what is the type of content. So here we can see for movie it is 71.7 percentage, and for TV shows it is 28.3%. Now on this chart we have for by this pie chart we have seen what is the percentage of TV shows and movies. Now how content is distributed over Netflix. Now we are going to see that how it is distributed. So this is, we can see from this chart, adult content, teen content, children content, family friendly and not rated. So we can see here by pie chart we choose this chart to show the percentage of type content present in Netflix. We also found most of the contents Netflix belong adult and teen. Another important insight we have seen, family friendly content is less in movies as compared to TV show. From here we can see that family friendly content is less from TV shows. Okay. Now for in our third chart we are gonna see top actor performing in movies and TV shows. So here we are giving bar chart. From this we can see Anupam Kher, Shahrukh Khan, and these all actors are top, amongst them. This is Anupam Kher is top performing actor, and same in TV shows we can see Takanisho Sakurai. He is the top actor performer. Through this bar chart we have seen that our top performer. Now fourth chart is who are the top directors directing movies and TV shows. So here we are gonna see that who is the top director from this bar chart. So as we can see, Jan Sitter, he is the top, and all the director by their performance based, this is shown. So this data shows us that which director is most performed. Now on fifth chart we are gonna see top countries, top 10 countries involve content creation. So here we can see United States is the most in content creation, and in second India, third United Kingdom, Canada, France, Japan, Spain, South Korea, Germany and Mexico. So here we can see by this bar chart we have seen that United States has the most content creator. Now, which country has the highest spread of TVs and movies, TV shows over Netflix? So by this bar chart we have seen, we are gonna see that which country has most content. So as we have seen earlier, United States are still on top, and in both, this is for TV shows and this is for the uh, movies. Okay, so here we can see for India, United and rest all of the countries. For TV shows is red and for movies is blue. Which genres are popular in Netflix? Now this from this chart we're gonna see that which genres is popular on Netflix. So we can see international movies are the most popular, then dramas, then comedies, then international TV shows, commentaries, action and adventure, TV dramas, independence movie, children and family, romantic. So here we can see that if we compare by this bar chart, then we can see then that romantic movies, children and family movies are very less popular than the international movies. Now in our eighth chart we are gonna see total number of movies and TV shows released as per added in Netflix. So here we can see that in which year how many TV shows and how many movies were added in Netflix. So in 2008 we can see 102 movies were added, and here we can see for same for the TV shows in 2008 only 22 TV shows were added in the Netflix. So these all are the year by year. uh, Here we can by this bar chart we can see that which year had most uploaded TV shows and movies. Now coming to our ninth chart, which is total numbers of movies and TV shows added per month. In this we have seen yearly, and now we are gonna see monthly. So this is monthly. So here we can see that in first of the month it is the highest, and rest all are uploaded in all the months. Now we are seeing total number of movies versus to TV shows added per day. There we have seen monthly, and now here we are seeing per day. So this is for per a month, and we can see that in first day, date 1, most of the movies and TV shows are uploaded. Means in the starting of the month only Netflix uploads the TV shows most. Now this is 11th chart. This is month wise number of content added in year of Netflix. So here we are gonna see that month wise number of content. So in this we can see that most of the contents were added in 2018 or to 2019. Now what is date wise number of content added in Netflix? So here we are gonna see that date wise number of content added in each year of Netflix. So here we can see by this chart, we can see that from 2015 onwards the shows are added more. Now, distribution of duration of content over Netflix. From this we can see that distribution of movies. So this is the duration. We can see that over movies and over the TV shows. So mostly it is duration of, here we can see now bar plot of TV shows duration. For now, from this also we are seeing that what is the duration of our TV shows and movies. By this chart we are seeing that majority of the Netflix duration is between 80 minutes to 120 minutes. This is by minutes. Now this is for heat map. Here we gonna see distribution of content rating in each highest content creating countries. So here we can see that adult content is most 47 percentage and the least is non-rated. So by this heat map we have gonna see that we gonna know that which content is highest, which content creates highest reach. Now doing some hypothesis settings testings. Here we are gonna null hypothesis, alternative hypothesis, null hypothesis, alternative this. For this we have seen there is no significant difference in the portion rating of dramas, movies and comedy movies on Netflix. There is a significant difference between proportional rating of drama movies and comedy movie on Netflix. So these are three statements and here we are gonna answer all them. You reach hypothesis and as a null hypothesis and alternative hypothesis. So here we can see there is no significant difference in the proportional rating of dramas, movies and comedy movies on Netflix. Performing statistical test to obtain p-value. So here we have got p-value 0. Means we conclude that there is a significant difference in proportional of ratings of dramas, movies and comedy movie on Netflix. The statistical test we have used to obtain p-value is the z-test for proportional. The z-test proportional was chosen because we were comparing the proportionals of two categories variable, dramas movie and comedy movie. So here we have done comparison between two movies, drama movies and the comedy movies. Now coming to hypothetical statement 2, state your hypothesis as null and alternative. So here we can see null hypothesis. The average duration of TV shows added in year 2020 on Netflix is not significant difference from range. Average duration TV shows added in 2021. So here we can see T value and P value. So the statistical test used to obtain the p-value is two sample t-test. The sample t-test was chosen because we were comparing the means of two different sample TV shows added in 2020 and TV shows added in 2021 to determine whether they are significant difference. Additionally, we assume that two samples have equivalent variances since it's unlikely that duration of TV shows added in 2020 and 2021 would have exact same variance. Now, hypothetical statement 3. State your research hypothesis as a null hypothesis and alternate hypothesis. Now here we are performing appropriate statistical test. So here we can see we conclude that the proportional of TV shows added on Netflix are produced in United States significantly different from the proportion of the movies added on Netflix that produces in United States. So the TV shows which are produced and the TV shows versus movie which are produced in United States are significantly different. The statistical test using obtained p-value is two sample proportional test. We choose the significant statistical test because to appreciate the comparing of two proportional and help us to determine whether the difference between two proportional is due to chance or not. Now featuring engineering and data proportion. Now handling missing values. As we can see that there were no missing values in our data sets. So here it is all are zero. Now handling outliers. Now in this we are handling our outliers. So we can see this is the although we have some anomalies in continuous features, but we will not be treated considering outliers as some of the movies TV shows has released on added yearly on Netflix. Now textual data proportion. So we can see our dataset size. Now this is for the new ones and this is our all the data sets which were having 1,75,807 columns, row and 14 columns. DF new ratings replace now binding of ratings in new data frame. So here we can see the ratings textual column for this is show ID type title director cast country date release rating duration listed description content lowering case. So here we have done all the case lower. Removing punctuation function to remove punctuation. Now here we have removed the removing punctuation from the content detail. DF new removing UR and removing words and digits content. So for this we are removing the content importing re and string. Now remove URL and remove words and digits content. Checking the observation after manipulation. So here we can see after we have removed all the words digit URL we can see all the names are been settled well than before. Removing stop words and removing white space. So here we are removing white space and stop words. So we can see the data. Now joining the list of words with space separator. So here we can see that we have done white separator and word with space separator. Now we can see our content. Now tokenization. This is NLTK download for tokenization. Checking the observation after manipulation. So after manipulation, this is our data. Earlier it was like this, and after the manipulation it has been separated. Text normalization. Now this is for the text normalization, creating an instant forward net, joining the list of word with the space separator. And now we can see. So we have used lamination instead of streaming our project because lamination produce a more accurate base word, unlike streaming which simply removes the suffix from a word. Lamination looks at a meaning of words and its context to produce a more accurate base form. Lamination can handle different inflection. Lamination can handle various inflection words, verb tense, and cooperative morphemes, making it useful or natural language processing. Lamination always produce real word that can be found in a dictionary, making it easier to interpret as the result section. So these all are the by reducing words to their base form. Lamination makes easier to understand the contents and meaning of the sentence, while streaming may only work well for English. Lamination effectively for many different languages. Part of speech tagging: tokenize the data, tokenize the text into words before process tagging. Now, checking the observation after manipulation. So after manipulation, here is our data's head, means this is our first view. Text vectorization. Now here text vectorization, after doing that we can see the shape of our data. This is our shape. Dimensionally reduction. Do we think that dimensionally reduction is needed? Explain why. In textual data processing, there are 3000 attributes are created in text vectorization, and this huge amount of column cannot be dealt with local machines. So we use principle of components analyzing PCA technique to reduce the dimension of this huge specs matrix. Now we are using the the vectorization process so that we can reduce our attributes. Dimensionally reduction. So our reduce after the reduction, percentage of variance captured by each component explained. So this is the value which we get. Now plotting the percent of variance captured versus the number of components in order to determine the reduced dimension. Now here we can see number of components and percentage of variance captured. This is a PCA analysis. It's clear from the above plot that 7770 principal components can be captured. 100% of variance. For our case, we will consider only those number of pieces that can capture 95% of variance. PCA. Now here we can see that transform shape is 7770, and rows column 500 5997. We have used PCA principal component analysis for dimensionality reduction. So here we have used PCA component. Now coming to ML model, machine learning model implementation. This will use for suggesting the TV shows and the movies for people. Determining optimal value for K using key alpha visualization from sklearn cluster. Now here we can see this disordered score elbow for K means clustering. So we can see that clustering dis disorder score. Here it seems that the elbow is performing at two clusters, but before blindly believing it, let's plot one more chart at that attribute same number of clusters and determine sellout score every point. So we have plotted one more chart. Here we can see this is the sellout score elbow for k-means. Computing sellout score for k in each. Importing needs libraries. For that we have again from sklearn cluster. Now this is the result we are getting k3 score. From the above plot we have seen it's very clear that sellout score is comparatively good for 4 numbers cluster. So we consider 4 clusters in k-means analysis. Now let's plot and see our data points look like after assigning to representative clusters. So here we have clustered in another chart. So we can see 1, -1, 0, 1, 2 and 3. We have seen 4 different clusters, but unfortunately the above peak is two-dimensional. Let's plot above figure in 3D using matplotlib library. So here we are using MPL and this is 3D. Here we have used 3D. Cool, we can easily differentiate all the 4 clusters with naked eyes. Now let's assign the constant the connect in the representative cluster by appending one more attribute in our final data frame. Now we have clustered value the data frame. Now implementation of above defined function and plotting the workload of each attribute. So here we can see when we are doing the cluster, we can see the find, love, family, life, man. These all are the most searchable things. Family take in this our cluster 1 we can see family, take, life, find, new. In our cluster 2 world, family, love, life, new. These are the most searched word. In list we can see international movie. In list here we can see that movies, comedies, children, families. Now our cluster in countries we can see United States, India, United States, United States here also. And in our last title we can see Christmas, movies, life, love, girl, one, movie, story, nova. These are clustering is now coming to the second machine learning model. Hierarchical clustering is a type of clustering algorithm used for group similar data points together into clustered based on their similarity, but passively merging on dividing cluster based on measures of similarity or distance between them. Now we can see the hierarchical clustered denograms. So this is for the TV shows and this is for the movies. A denogram tree-like diagram records the sequence of merging more distance of vertical lines in the denogram distance between those clusters. The denogram can easily optimize the clusters to before assigning the values of cluster. Let's check the CLOL score of algorithm clustering and follow the bottom-up approach. Now here from the above slope score, it is clear that the two clusters are optimal value. Maximum Silcott's score which is also clear from the above diagrams that is for two clusters and the including distance are maximum. Let's again plot a chart to observe two different former cluster. Now again we have plotted a chart. Again plot a three-dimensional chart for clear. This is the our three-dimensional plot chart, 3D chart. Here we can easily differentiate between two clusters with naked eyes. Now let's assign the content, movie and TV shows in their respectively clustered by appearing one more attribute in the final data frame. Now again we have done a final attribute. So in here we can see find, new, to, family, love, life, take. These all are the clusters. Description here. Implementing the above defined function and plotting the word cloud to each attribute. We have seen girls, Christmas, love, and all of these. Now ML model 3, building a recommendation system. Now in this we are gonna make a system so that Netflix recommend the person what he wants to see. So here we have made this by sklearn matrix pairwise. Let's check how our recommendation system is performing. So a person who search call now for movie and the recommendation has given of that types of movies, which is like romantic movies. So all the romantic movies are recommended. Now testing for Indian movies. So Indian movies, Zombieland, non-Indian movies. So this is a non-Indian movie. Now it is given recommendation. This is all movies like zombies and etc. Now Indian TV shows. So if a person is searching Zindagi Guzar Hai, then they are getting these all movie shows, TV shows for recommendation. Non-Indian TV shows. So if anyone search vampire, then this is recommended by the Netflix. These all are the same types of TV shows as vampires. Now which valuation? We have chosen silhouette score over distortion score, also known as initial or sum for squared distance, as equivalent matrix as its measure how well each data point is in clustered is separated from the other cluster. It ranges from 1 to 1 with high values indication. Better clustering separation, a silhouette score closed in 1 indicates that point well matched to its own cluster and poorly matched to the neighbor clusters. A score close to 0 indicates that data points is very close to boundary between the two clusters. A 1 to 1 indicates that point probability assigned to the wrong clusters. Now which ML model we have made for final prediction and why? So the model we have made is we have getting comparably high silhouette score in K means clustering, and resultant clusters are very well separated from each other and have shown three-dimensional inclusion. Now movies make up to two-thirds of Netflix contents TV show compromising the remaining one-third. Adult teenage categories prevent on Netflix while family friendly content is more common in TV shows than movies. Indian actors dominate Netflix movies while popular Indian actors are absent from TV shows. These all are the conclusion which we have get from our analysis. You can see TV shows are TV shows additional additions on Netflix have increased since 2018, while movie additions have decreased in 2020. Fewer movies were added compared to 2019, but more TV shows were added. So these all are the results. Conclusion. Now, in getting these data sets, external sources such as IMDb, rating book, clustering plans base types clustering can add numerical integrates discover by integrating in additional data. A more comprehensive recommendation system should be developed, offering enhanced recommendation to user. This system could be deployed in. Thank you.